What is RESTful API? A RESTful API is an application programming interface API that uses HTTP requests to get, post, put, and delete data. It referred to as a RESTful web service is based on the representational state transfer technology, an architectural state and approach to communication often used in web service development. How RESTful API work? A RESTful API explicitly takes the advantage of HTTP methodologies defined by the RFC 2616 protocol. They use GET to retrieve a resource, PUT to change the state of or update a resource, which can be an object, file, or block, POST to create that resource, and delete to remove it. With REST, network components are a resource you request access to, a black box whose implementation details are unclear. The pre-assumption is that all calls are stateless, nothing can be retained by the RESTful service between executions. The RESTful architectural state describes 6 constraints. These constraints apply to the architecture were originally communicated by Roy Felling in his doctorate dissertation and define the basis of RESTful style. Unified interface. The unified interface constraint defines the interface between clients and servers. It simplifies and decouples the architecture, which enable each part to evolve independently. The 4 guideline principles for the uniform interface are resource-based, manipulation of resource through representations, self-descriptive messages, hypermedia as the engine of application state. The second constraint is stateless, and REST is an acronym for representational state transfer. Statelessness is key. Essentially, what this means is that the necessary state to handle the request is contained within the request itself, whether as a part of the URL, query string parameter, body, or headers. The URI uniquely identifies the resource and the body contains the state or the state change of that resource. Then, after the server does its processing, the appropriate state or the piece of state that matter are communicated back to the client via header, status, and response body. The third one is cacheable. As on World Wide Web, clients can cache responses. Responses must therefore implicitly or explicitly define themselves as a cacheable or not to prevent client reusing stale or inappropriate data in response to further requests. Well-managed caching partially or completely eliminates some client-server interactions, further improving scalability and performance. The fourth constraint is client-server. The uniform interface separates clients from servers. This separation of concern means that, for example, clients are not concerned with data storage, which remains internal to each server, so that the portability of client code is improved. Servers are not concerned with the user interface or user state, so that server can be simpler and more scalable. Server and clients may also be replaced and developed independently as long as the interface is not altered. The fifth one is a layered system. A client cannot ordinarily tell whether it's connected directly to the end server or to an intermediary along the way. Intermediary server may improve system scalability by enabling load balancing and by providing shared caches. Layers are also enforce security policies. The sixth one is optional. It's code on demand. Servers are enabled to temporarily extend or customize the functionality of a client by transferring logic to it that it can execute. Examples of this may include compiled components such as Java applet and client-side scripts such as JavaScript. Complying with this constraint and thus conforming to REST architectural state will enable any kind of distributed hypermedia system to have desirable emergent properties such as performance, scalability, simplicity, modifiability, visibility, portability, and reliability. That's an introduction to RESTful API.